All right, welcome back. Going to section 2 of our unit 5, and we're still looking at sampling distributions, the normal distributions, but we're going to be looking at sample proportions, and we're going to be looking specifically at using one proportion and going through our 4-step process to see if it fits within our range. Okay, so first things first. We've got to talk about the difference between p and p hat. So p and p hat are two variables here at the top. They are very similar. The difference is that p, lowercase p, is the parameter. Now, if you remember way back at the beginning, back in like unit 1 or 2, when we talked about it, parameter was the actual value of the proportion of a population. So think of like a presidential election. If we're looking at that part, they can do all these polling, but you don't know the actual value until whenever all the votes have been counted. So then once all the votes have been counted, then you have that proportion, that percentage. That is P. So the actual fixed number that we have, okay, for the entire population. Very hard to find what it would be. We wouldn't really know exactly. And so what we're doing here is we're trying to use a smaller sample to estimate what it would be within a percentage. P hat is the sample proportion. So instead of taking the entire population, you take a smaller subset of 100, 500, 1,000 people, ask them and go, okay, what's your opinion on this? And you do all your math and you go, oh, it's about 48%. And you go, okay, 48%, that is what we think is close to the actual population proportion or percentage that we have. But instead of counting everybody, you just do a smaller sample. Okay, so that's the difference between P and P hat. So we're trying to find P, but we can't, so we're using P hat to help us. Okay, that's essentially what we're doing here. Okay, so let's say you have two deck of cards. You have 50 black cards and 50 pink cards, and you mix them all together. So you mix them all together into a hat or a box or whatever it is. The P, the population proportion, would be 0.5. There's 50 here, 50 here. Okay, so the population P value would be 0.5 for the population of, let's say, pink cards or black cards. Doesn't matter which one. But it would be 50-50. This is what it would look like. So completely down the middle. Now, if I gave you this and I said, okay, pull out 10 cards, will it always be 5 and 5? And the answer is no. Whenever you take that small sample, what ends up happening is that you get a range of values. You could only pull out pink cards, or you could only pull out black cards. Or you could have 3 pink, or 6 pink, or 8 pink cards. You've got that complete range that you could have overall. And that's the variability that we have. The larger the sample is, the less variability we're going to have, because the more numbers you throw into it, the more it's going to balance out. So if you just do 100 samples where you pull 10 and you throw them back, and you pull 10 more and you throw them back, you keep doing that over and over and over again, what's going to happen is that you're going to see that one number is probably going to be more common than the other, and that most common one is going to be that 50-50 split. But what will happen is that it will slowly drop on the chances for each side moving down. So 4 and 6 pink cards would be about the same, but it would be less than 5. 3, 7 would be about the same, but less than 4 and 6. 2, 8, 1, 9, 0, 10. It makes that nice little bell curve, which is what we're talking about here. Okay. All right. So if you combine all these, you could use a calculator to basically create this. What you would do is you would just say what your P hat would be. So your probability, you put that in L1. So how, 1 card, 2 card, 3 card, 4 card, whatever the probability is. And then make a frequency chart. And then you can use the L1, L2 and a 1-var stats, and it can tell you the mean, the deviation, etc. So I can tell you all that stuff. Okay, so moving on to here, let's talk about the characteristics of our sampling distribution. So first off is the center. So do we have any biases? That's what we really want to know. Are we overrepresenting or underrepresenting somebody in a population? That's one thing we want to worry about. If the sample is unbiased, then the mean value that we find is probably going to be fairly close to what the actual population value is. So as long as our gathering of our sample is unbiased, we're probably going to be good. Okay, so that's the one thing we want to check with our center is it unbiased? Because if it is fairly unbiased, simple random samples are great for this. Then it's going to be close to what the actual value is. Next up is our spread. The bigger the sample, the smaller the variability that we have. So if you take a sample of 100 people, or if you take a sample of 1,000 people, the one with 1,000 people is going to narrow down what that mean could be. Okay, that plus or minus that you have. It doesn't matter the size of the population itself. I could take a sample for people in San Diego, and I could take a sample of people in California. I could make either one have a smaller variability depending on how large of a sample I do for that one. So it's not a percent of the population. It's just the larger the sample, the less variability you have. Okay. What you want to do though is that you want your population to be large enough that when you take your sample, you're not getting so close to what the actual population is, because then you're almost defeating the point of doing a sample. A sample is, I've got 1,000 people I need to check, but I can't do it for 1,000, so I'm going to check it with 60, because I can do it with 60. If there's 1,000 people and I'm going to do it with I'm going to check 800 of them, why not just do the extra 200 and get everybody else? So you want to keep it on the smaller side, but you don't want to basically overdo it, because then what's the point of that sample? Okay. One thing you want to do is about the 10% condition for your spread. So when you're checking spread, you want to do your 10% condition. Typically what it is, you want your sample to be less than 10% of the actual population. So whatever the entire population is, you want to do 10% or less of it. So if there's let's say your city has 1 million people in it, you want to take less than 10, you want your sample to be less than 10% of 1 million people, which would be 100,000. So you want your sample to be less than 100,000. See, when you think about something that has a lot of people in it, it's very hard to get close to that threshold, because it's asking for a lot of people. When this is met, so when you're under 10%, okay, so when your sample is less than 10% of the entire population, then you can find your standard deviation by using this, which would be the probability that you found, or the predicted probability, the population probability, times 1 minus, so the probability that it doesn't happen, divided by n, which is your sample size, and then you take your square root of that sample size. Okay. All right, so going back to SOX SOCS, we have our shape, outlier, center, and spread that we're going to be looking at. So the first one here is up to our shape. So with these being normal distributions, we want them to be as close to a normal curve as possible. Okay, so that should be the shape, which means that they are unimodal. There should be only one hump, and then they are symmetrical, so they're not skewed either way. We want the sample to be large enough to be able to do it, but we don't want it but it's not wanting to be too large. So, and we'll get to that when we talk about the spread. The large counts condition is what's going to make it so, or what's your check to make sure that the sample is large enough, which is basically, since we're dealing with proportions here, the sample size that you took, you multiply it by the yes proportion and the no proportion, depending on what it is. Both of those need to be more than 10. So there needs to be at least 10 in both camps of it, either being the yes side or the no side. If these criteria are met and all the other criteria, then we can say, yes, it's probably going to be normally distributed, or at least approximately normal for us. Next up, we have our outlier. There should be no outliers. So if it is a normal distribution or approximately normal, there is no outlier. We don't even really have to check it. Okay, we don't really talk about it. If it says that it's normally distributed, we just kind of skip over the outlier part. Next after that is our center. Our center, as long as it's an unbiased sample that's being taken, then either random assignment or randomly collected, then it should be unbiased, which means that the mean that we got should fall into approximately that range that we need. Okay, so the mean should be close to what the actual parameter is. Okay, so again, unbiased for our center. After that, we have our spread. Our spread, it all depends on the sample size. The larger the sample size, the smaller our spread is going to be. It's going to narrow it down. But we don't want it to be over too large, because then it kind of defeats the purpose of it. And so we use what's known as the 10% criteria, which means that we have to have at least 10% or less of the entire population be sampled. Which, if you're looking at something large enough, getting 10% is really hard to do. But the formula for your standard deviation is just p times 1 minus p, so the probability of it does occur or probability that it doesn't occur all over the sample size, and then you take the square root of it, and that's going to be what it is. So the larger the sample size you have, the smaller the deviation is going to be, because that n is going to make it a larger number that has to be divided. All right, so let's say you have an example. So you have 47% of all adults think that of adult women think that they do not have enough time for themselves. In an opinion poll, they interviewed 1,025 people, randomly chosen women. Again, it should be precisely stated that it's women here, because that's what the question's about. And then they recorded their response into a proportion. The question that we're asking is, what's the probability, or what's the chances that the sample that we got was within 2 percentage points of what the actual amount is? So if that 47% is the actual amount, what's the probability of those 1,025 women will be between 2 percentage points below 45 and 2 percentage points above 49? Okay, so that's what we're going to be doing, showing our work. So first thing we want to do here is we do our state. So we have state, plan, do, and conclude. First thing is state. We basically tell all of the data that we have, or all the information that we have. First one listed here is the probability we're trying to find. We're trying to find 2 below and 2 above that 47, so we would state from 0.45 is less than or equal to p hat, which is less than or equal to 0.49. So you've got your lower and your upper bounds there, plus or minus. We've stated what p is. It's the proportion of women who feel they do not have enough time for themselves. And then also in here, we're stating off what the n is and what the p value is, what the parameter was stated. By giving out all this information, we're able to now not have to look back into the problem. If I give somebody all of this information, they know everything about the problem that they need to know. And that's what state really does. Plan, we have to go through our normal, independent, and random. Okay, so our random, it states in the problem that it was a random sample, right here, randomly chosen women, right there in the problem. So there, that covers our random. So that means that the mean that we should have is about that 47.47. Next up is independent. This is your 10% criteria. 1,025 is less than 10% of all women in the world, which easily covers that 10% criteria that we have. After that, we have our normal distribution, or our standard deviation formula. So 0.47, which is the probability for this situation, and then 0.53, which is the probability that it's not, divided by how large our sample was. So our deviation that we're working with is a 0.016, or about a 1.6% deviation left and right. After that, we talk about our normal, which we want to make sure that each one is larger than 10. You don't actually have to multiply this through and get the number, so you don't have to go 1,025 times 0.47 and 1,025 times 5.3 or 0.53 to show that it's more than 10. Just by showing this, obviously these multiplications are both greater than 10. And so that's all you need to show. So based off of this, we know that it's approximately normal. Since it's independent, we know that it's going to have that deviation, and because it's stated that it's random, we know where our mean is. Next up we have is our do, and so our do is our formula. So we've stated what our normal distribution is, which is up here, the mean of 0.47 and a deviation of 0.016. Our probability, which we stated back in state, was 0.45 to 0.49. And then you want to show the z values. So calculating the z values is just like you calculate it any other time. Negative 1.25 to positive 1.25 because it's the even amount. From there, normal CDF, you can use your calculator the rest of the way or using a table, depending on which one you want to do. The calculator is just easier and quicker. So normal CDF, lower limit, upper limit, mean, deviation, or you can use the actual values of 0.45, 0.49, and then 0.47 and 0.016. Probability we got is approximately 0.79. All right, so after you've done all that math, what you're going to do is you're going to do your conclusion, in which your conclusion is basically the wrapping up of everything that you found. It's like a sentence or two that you're just going to wrap everything up. So mine written up here is that the probability that this sample of women will have a p-hat within 2 percentage points of the true value is 0.79. You want to make sure that you state what your probability that you found was, okay, so the chances of it occurring. You also want to state what the probability that you were trying to find was, the plus or minus 2 percentage points essentially in this problem. You probably want to be a little bit more descriptive about what you're trying to find, not just the sample of women. Probably should have written in this about the height of the women, because that's what we're looking at. Or no, not the height of the women, that was the previous section. The being able to have time for themselves. So you just want to make sure that you state that type of stuff in this problem. Okay, so it's just a wrapping up sentence or two, wrapping up of what you found.